So here's our slice. All right. So volume is the sum of all of the areas of the slice. What's the area of the slice?
Diameter.
It's pi
R squared. What is our R?
f square root of x.
Square root of x is our R.
Yeah.
Good job, Charles. So our area is pi r squared.
Oh.
Then to find the volume, you take the integral of our area, pi r squared, and you take it over our integral, which is what?
0, 1.
0 and 1. I think that's it. Let's find the integral. What's the integral of that volume? That, what do we call it, half a sphere? The integral is half a sphere. So your Thanksgiving, man?
Ooh. That's unfortunate.
Yeah, that is. There you go. Thank you very much. Other thing is all over today. Bunny, would you go put that on the board for me, please? She's showing all the order. Muchas gracias. It's good. Would you care to explain?
Sure. So we can take pi out because it's a constant. So we have pi times the integral of x dx over 1 over 0 because the square root of x squared is x. And so volume, well, so then we have pi x squared over 2 because it's the integral of x, bar 0, 1. And then we plug in the 1 and the 0, and we get v equals pi times 1 squared over 2 minus pi times 0 squared over 2, which leaves us with pi over 2.
Very good. Muy bueno. Anybody get anything different than pi over 2? No? Fantastic. All right, but before we, yes, sir.
So looking at that, when you do a slice, wouldn't the radius be the y value just?
The y value. Okay, so if our slice is volume, remember we rotated around the x-axis, right? So our radius is right here. So it is the y value, but it's the y value for at any point on our function. So it'd be the y value here, the y value here, the y value here. And what's the y value for this function? Okay. All right. Now, what if we had a casa? What if we had a, you can erase that, we had a figure bounded by y equals x and y equals x squared. And while you're doing it on the board, you can write that on your paper as well. Y equals x. Yep. That's it. And what if we were to take that figure and rotate it about the x-axis as well? What would that look like?
Area between them?
Hmm?
The area between them around?
Yes, the area between, the area bounded by those two, so this,
Like a cone on the outside and then like a curve.
who draw it for us? Once you have a vision in your head, I want you to put it on the board. We can all see. We can all see your vision. You don't have to do it. Very good. I don't know why everybody didn't stand up and shout when I asked them if you had any Picassos in your class. That's two people that did an excellent drawing, excellent representation. All right. Now, what is the difference between this object and the previous object? It's hollow. There's space missing. There's space missing. So if we took a slice of this object in order to apply it to our formula for volume, which is the area, what would that slice look like? Two circles. Something like that. All right. Now, if this is the area that we're trying to find the volume for, this ring around the center, how would we find the volume of this object? That's area.
Subtract the small one.
Large one. Subtract the small one from the large one. Nice. So, you need to have the area for this. Radius 1 and radius 2. What we're going to do is take area 1 minus area 2. But before we go and just throw that into our formula, let's think about the area of this object. If we were, as we did recently, find the area between these two curves here, what procedure would we have to go through? David?
First we'd have to set them equal to each other to find the points of intersection.
Set them equal to each other, find the points of intersection. What are the points of intersection of this particular curve here?
X equals 1.
0.
There's 0, 1, 1.
0 and 1. All right. Sarah, what would we have to do next to find this area between these two curves?
You would have that, and then that gives you the and then you would figure out which one is on top and bottom.
Which one is on top and which one is on bottom? And what would we do with our top and our bottom?
You would subtract the bottom from the top.
Subtract the bottom from the top. All right, so not leaving that pearl of wisdom behind. If we wanted to find the area of the outer circle, what's the radius of the outer circle? Where is the radius of the outer circle? That's on the upper one. So that's going to be this y value here. So if this is our upper function and this being our lower function, what would the area of that outer circle be? What's the top?
F of X.
F of x. What's the bottom?
F of X squared.
Just the outer circle. Just the outer circle.
The radius of it?
Oh, we need 1.
1.
Yeah.
Right there.
F is negative.
You mean the outer circle on the outside?
If we were going to find the area